Hi, my name is Alan Gray. I'm a research assistant here at the University of Southampton, and I'm going to speak about wavelength transformation cameras. So while our primary interests are in the detection of mid-infrared signals, we would ideally like to be able to use cheap, efficient silicon detectors. And silicon, alongside some other semiconductors, does not directly detect mid-infrared light. And materials which do typically require cooling and sometimes the application of liquid nitrogen. So here in Southampton, we apply periodically poled lithium niobate in combination with other source lasers such as neodymium YAG to wavelength convert the mid-infrared light to something which can be detected using these silicon detectors. An example of this nonlinear process is the combination of two 1064 nanometer photons to create a 532 nanometer photon. And this is the basis of a green laser pointer and is enabled by simple energy conservation. And while that is just one example of a 3-photon process, we also have some frequency and difference frequency generation available to us. And this will allow us to take 3.3 micron photons and combine them with a 1064 nanometer photon to create a new approximately 800 nanometer photon. And this is now readily detectable on a silicon detector. And we have used this process recently to demonstrate a gigahertz rate transmission of mid-infrared signals for communications transmission, where final detection is performed using silicon avalanche photodiodes. So what we've been working on so far is our design and characterization of our upconversion setups. We've been investigating the transmission of laser noise from our commercial sources to our final upconverted signal. And we've also been designing and building our optical system for the transmission of images through multimode waveguides for final image recognition on the detector end. Our applications for this type of technology are primarily seen within the military. We just had a new DSTL PhD student start. Our collaborations with companies are typically through our membership in projects such as Pioneer Gravity and QT Assemble. And we work a lot with Covision, which is the university spin-out. Our application of the periodically poled lithium niobate waveguides, which have been designed here at Southampton, we anticipate making them wider for multimode operation to eventually use linear array detection to characterize and detect these mid-infrared images after they've been converted to something which can be detected on a commercial linear array detector. Thank you.